Okay, welcome back. In this video, we're going to discuss what's referred to often as finding all the nth roots of a given number, given complex or real number. I like to think of it more in terms of solving an equation of the form z to the nth power equals a given complex number. So we're thinking about z and n. There's z and w, pardon me, being real or complex numbers here, finding all solutions, real or complex, to that given equation. All right, so let's start with an equation we can actually do without much work in terms of the polar form of complex numbers, which is this one, z to the fourth equals 16. If we subtract 16 from both sides, we would have z to the fourth minus 16 would equal 0. We could use difference of squares factoring here to rewrite this as z squared minus 4 times z squared plus 4 equals 0. Then we could set each factor equals 0 to get z squared minus 4 equals 0, z squared plus 4 equals 0, and then simply to solve these resulting equations, so we would get z squared equals 4 and z squared equals negative 4 respectively. Taking the square root, we would get 4 solutions. One would be plus or minus 2. The other one would be that z would equal plus or minus the square root of negative 4, which would be plus or minus 2i. All right, so that was one we could have done with some of our earlier work. Now, what I want to just look at here is the graphical interpretation of this. So if we think about plotting these ordered these complex numbers, in the xy plane, what are we looking at? What points do we have? Well, we have positive 2, we have negative 2, and then we've got 2i and negative 2i. All right, my scaling might not be perfect here, but that's all right. All right, but this is kind of going to showcase how we can do this in a little different way, which is going to lead us to our next example. So what I want to look at here is, let's think about the polar form of the complex number 16 itself. All right, so 16, the real number 16, we could rewrite as its radial length, which would be 16 times e to the I times the angle, would be the angle theta in this case, could be 0. All right, that's one way to write down the complex number in polar form. All right, so let's call that solution, or that number, w sub 1. All right, so the first way we can write this down. There's 4 solutions to it. There's going to be other ways to write that. Now, what we're eventually going to see is we would want to solve this by, again, to get rid of a 4th power, we're going to take the 4th root of each side. So what we're going to eventually do is take the 4th root of 4 different versions of the polar form. The first one being 16 times e to the I 0, e to the I 0 power, e to the I 0 power. The second one, we would just need to find a coterminal angle. So the radial, or the length of the complex number is 16. What's a coterminal angle to 0? Well, that would just be simply 2 pi. Then the next one, w sub 3, we'll call it, will be 16 times e. Adding another 2 pi, we would get I 4 pi. Adding another one, we would simply get 16 times e to the I times 6 pi. All right. Now, when we go through and we compute the 4th root of each one of these individual values, we're going to get, I'm going to skip that part just for the length of the video here. What we would end up seeing here is that we would get in order 2, and then 2i, then negative 2, and then negative 2i. All right, and we're taking a 4th root, and what we're going to see is we're dividing the 360 degrees, or 2 pi radians, or 360 degrees, up into 4 pieces. So if I divide that by 4, and we saw in our previous video that when we take a square root, we'd be dividing the angles by 2. In this case, we're taking the 4th root, we're going to divide the angles by 4. That's going to be dividing 360 degrees up into 90 degree segments, or pi over 2 into pi over 2 pi, pardon me, 2 pi divided by 4 would be pi over 2 into 2 pi pieces. So looking up at the picture here, once we know what the first one is, we're going to rotate that 90 degrees, or pi over 4, then rotate it to get the next one. Rotate another pi over 2 to get the next, another pi over 2 to get the next, and then we'd be back to the original one. All right, so let's put that idea to use to find some other ones, some other nth roots of complex numbers. Okay, so the next one we're going to do is we're going to do the same equation, except almost the same equation, except change that 16 to a negative 16. All right, so very similar equation. So now what we want to do here is we want to think about how can we express the number negative 16 in, which is this real number, in polar form. Well, what would our angle be? Our angle theta would be, in this case, pi. All right, so when we look at this, we want to think about, okay, our first number, we're thinking about this in the format z to the fourth equals w, but we're going to express that number negative 16 as the length, all right, the radial length, it's 16 units from 0, all right, so that's going to be 16, and then it's going to be e to the I times theta, which is pi. And we've seen in our previous work that we can express a complex number in rectangular coordinates only in one way, but in polar coordinates we can do that in an infinite number of ways using coterminal angles. So the next one we're going to write down would be 16, and then a coterminal angle to that would be 3 pi. All right, so 3 pi times I, or I times 3 pi. The next one, again, another coterminal angle would be 16, and then e to the 5 pi times I power, or I times 5 pi. Oops. And then the last one would be, and we're only going to do 4 in this case because there's going to be exactly 4 nth roots of negative 16. It will be 16 and then e to the I times 7 pi power. Okay, now, again, to get rid of a fourth root, what we want, our fourth power, we want to take a fourth root. So again, we're going to take the fourth root of each one of these values, and that's going to give us the individual fourth roots of negative 16. So what we want to do is take the fourth root. Remember, raising the fourth root is the same as raising the 1/4 power of 16e to the I times pi power. Now, like we've seen in our previous work, we need to distribute this exponent to each factor, which results in doing the fourth root is 16, and then we're going to multiply the exponents. So it's going to be I times pi over 4. Okay, now for this, the fourth root of 16 comes out to exactly 2. All right, so we'd have 2 times e to the I pi over 4 power. All right, now I'm still continuing this calculation. We would have 2 times, now in this case we would have to use Euler's formula, so then that would be, as we showed in the previous recording, cosine of pi over 4 plus I sine of pi over 4. Distributing, or putting in, what the exact values for cosine of pi over 4 and sine of pi over 4, we would get square root 2 over 2 in each case. Then if we distribute the 2 through the parentheses here, it would cancel each of these denominators out. So our first one, our first nth root of negative 16 would be the square root of 2 in rectangular form plus the square root of 2i. All right, now that's going to be on, if we compute the angle, all right, we already knew what the angle was, and it's almost easier to plot the points leaving it in polar form. It would be pi over 4. All right, so now let's go through and plot that first one, and then just using that we can plot the other 4. If we needed to find those in rectangular, the other 3, we found 1, we could find the other 4 using the same technique. It would just be taking the fourth root of each of these other 3 W2, W3, W4 values we wrote down, or versions of the polar form for negative 16. I'm just going to do one of them for this example. We'll do one more equation after this. But let's plot that point. All right, so I'm just going to draw an XY axis here, just a quick sketch. Now we're at a 45-degree angle and we're 2 units away. So just kind of visualize 45-degree angle, go 2 units away. Now taking a fourth root, we saw before that we would be taking 2 pi radians and then dividing it by 4. That would give us a rotation of pi over 2. So the next one would be at a 90-degree rotation or counterclockwise, which would be at 135 degrees or 3 pi over 4. And you'd be at, that would be your next fourth root. And then we would go another 90-degree rotation, go 2 units at 5 pi over 4, and then go another 2 units at 7 pi over 4. So there would be your 4 nth roots of negative 16. And we only wrote one of them down in rectangular form, which I'm just going to underline here in green. We could certainly write the other 4 down. All right. They're going to be that this first one was 2e to the I pi over 4. The next one would be 2e to the I 3 pi over 4. Then it would be 2e to the I 5 pi over 4. And then 2e to the I 7 pi over 4. Okay. And there's all 4 of them. Now, again, what we would see is that they actually lie on a circular radius 2. My picture's not perfectly drawn to scale. We could, just like we did with the first root, rewrite that as in rectangular coordinates or in rectangular form. All right, so we're going to do one more example in this video, which is finding all the cube roots of a certain equation. Okay, so that equation we're going to look at is z to the third power equals 27. All right, so we're going to do the exact same thing we've done before. 27 is a real number, so we're thinking about this right side being w. There's going to be 3 cube roots of 27. The first one we're going to get by taking the cube root of 27 is the radial length, and then the angle that's on the positive x-axis is going to be 0. Oops, not theta, 0. So it's going to be 0. Now to write the others down, we're going to write down an equivalent form of the complex number 27, the real number viewed as a complex number by using a coterminal angle, so it would be 2 pi. We could find another complex number by, again, adding on 2 pi or rotating by 360 degrees, so it would be 4 pi. All right, now to solve an equation that has a cube in it, we would take the cube root. So that's what we're going to do here. We're going to take these and take the cube root of each one of these to solve for z, right? Because again, z really would then equal the cube root of 27. But what we've shown is that there's really 3 different ways. If we did 6 pi and 8 pi, we would just repeat these values. There's 3 different ways we can write down the number 27 in polar form. That's going to lead us to the 3 cube roots of 27. All right, so cube rooting these, let's do that now. All right, so taking W1, the cube root. So one of the solutions is going to be the cube root of W1, which is the cube root of 27e to the I0 power. Again, that's the same as the 1/3 power, so it'll be 27 to the 1/3, and then it'll be e to the I, and then it'll be 0 times 1/3. This would simply give us the cube root of 27, which is 3, and then it would be e to the I times 1/3 times 0 was still 0. This would give us just 3 in rectangular form. Fine. All right, so that's the first one. Let's write the next 2 down. Next solutions, that's one of our answers right there. I'll underline that one in yellow. All right, the next one would be the cube root of W2. Okay, and that's going to be the cube root of 27 e to the I and then 2 pi power. All right, again, this is the same as raising to the 1/3 power, so we're going to have 27 to the 1/3 power, and then we're going to multiply our exponents here as we've seen before, so it's going to be e to the I 2 pi over 3 power. 27 to the 1/3 power, that's the cube root, that's just 3. That's going to happen for the next one also. Now this next one, I'm just going to skip this for here, but if we do cosine of 2 pi over 3, cosine of 2 pi over 3, that's the reference angle is 60 degrees, it'd be negative 1/2, and then sine of 2 pi over 3 is the square root of 3 over 2i. Right, so if we wanted to, we could rewrite that in rectangular form. The next solution would be negative 3 over 2 plus 3 square root 3 over 2i. Okay, let's do the last one. The last one will be the cube root of W3, which would be the cube root of 27e to the I 4 pi. And then likewise, we would get 3 times e to the I 4 pi over 3 power, which if we want to write this out in rectangular form would be 3 times cosine of 4 pi over 3. That's going to be positive 1/2. Sine would be negative square root 3 over 2i. So we could also express this in rectangular form, 3 over 2, and then minus 3 square root 3 over 2i. All right, so let's just plot those, and we could compute those, convert those to decimals, and then plot. Let's just give just a quick freehand sketch just to wrap this up. So we'd be talking about going 3 units from 0. All right, there's our first cube root, and that's at just 3 on the imaginary axis. Then we'd be going to an angle of 120 degrees. Okay, and then just 4 pi over 3. Again, what we're thinking about doing here is we're rotating by 120 degrees, or 2 pi over 3. Okay, and then we're going to do another rotation of 120 degrees to get to the next angle or terminal side that we're going to land on, and then we'd be coming back 120 degrees to get back to where we started. All right, so then the next one we would end up plotting would be 3 units away from 0 along that terminal side. Then the third one that we computed would be, again, 3 units away from 0 along that terminal side of that angle. So, oops, there is computing and then plotting the 3 cube roots of 27. Okay, so if you need to write them in rectangular form, we just showed how to do that, and then we just graphed it at the end.